Number 15 has us filling in a bunch of blanks in order to complete each number sentence. Now, the first one we are going to try and do is 14 plus something is equal to 29. Now, just like we have been talking about with variables, instead of this blank, you could put a letter in there, and you would be solving for what the letter represents. So now that we have talked about variables, you have a second way to do this problem. But let's go ahead and look at the first way first. So the way that you can approach this at first could be with a number line. You're at 14, and you will need to get up to 29. You need to know how many spaces are in between, because that is going to be what you fill in there. So with 14, you have 15, 16, 17, 18, 19, 20. So that's going to be 20. Then 21, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Not drawn to scale, by the way. Okay, so between the two, this number of tick marks is going to be the number that belongs in that blank space, because if you add that number of tick marks to 14, that is what is going to get you to 29. So let's see, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 tick marks between 14 and 29, so your final answer should be 14 plus 15 equals 29. Now, I said there was a second way to do this now that you know what variables are. Let me show you what I mean. So if I instead was going to use a variable instead of my blank, they are interchangeable. They mean the same thing, they're just placeholders. So if I were to put an n there, I could actually solve for it. The way I solve for it is getting rid of this 14. It is technically a positive 14 right now, so I'm going to have to subtract 14 to eliminate it. This is what the homework from 2 nights ago was all about. So a positive 14 minus 14 is going to be 0, because plus 14 and minus 14 are opposite. So when you combine them, you will always get 0. So that is going to cancel out, leaving just the n on that side of the equation. And then you have 29 minus 14. 29, 14, 9 minus 5 is, or 9 minus 4 is 5, and 2 minus 1 is 1. So yes, I got ahead of myself. That is supposed to be 4. So it's a 29 minus 14 equals the 15. So n in this case would be equal to 15, which is originally what you got for your blank. So if you don't want to use the number line and you don't want to do chip models or whatnot, you can substitute in a variable for that blank space and solve for it with the tools that we went over. All right, so for part B, you have 12 minus 4. There's really nothing special about this one. You just do your subtraction like you normally would, and look, you get the answer. Woo! So the answer to part B is 8. All right, so part C, you have a blank minus 12 equals a negative 2. So in this case, you could use a number line, you could use a chip model, you could use a variable. I'm going to go with the chip model for this one. So I have 12 negative chips. So just finish drawing them. I have 12 negative chips, and I end up with 2. So I need to know how many chips I have to write here in order to cancel out all but 2, which is what I'm left with. So in order to cancel all of those ones out that I crossed out, I have to have positive chips in order to do that. So let us count how many positive chips I need for that. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I were to draw 10 positive chips, that is how I would be able to cross those negative chips out, because I'd cross out a positive, cross out a negative, cross out a positive, cross out a negative. I would run out of positive chips before I was able to cancel them all out, but it does leave me with the 2 that I needed to be left with. So the answer for the blank is a positive 10, or just 10, because you have those 10 positive chips that when combined with a negative 12 chips will leave you with 2 negative chips. So that is a positive 10. However, if you did not want to use a chip model, you could go back to using the variable. Let's see, what letter do I want to choose this time? Let's choose a K. So I have K minus 12 equals a negative 2. So if I want to get the K all by itself, I need to get rid of this subtracting 2, or the minus 2. So I need to do the opposite of subtracting 2, or write the opposite of negative 2, or 12, sorry. So I get rid of this negative 12, or minus 12. So I need to add 12, or have a positive 12 to both sides. So these 2 on the left side cancel each other out, because a negative 12 plus a positive 12 is going to be 0, because these 2 are opposites, and anytime you add opposites together, they will always be 0. So I'm left with a K on that side, and then I have a negative 2 plus 12. So I'm adding numbers with different signs, so I have to subtract them, and then I keep the sign of the larger number. So I have 12 minus 2 is 10, and then the larger number in this case is going to be 12. So this is going to stay a positive 10. So my answer for 15, again, is going to be that 10, or positive 10, but this time I used a lovely variable to solve for it. Either way is acceptable, so long as you come up with the right answer and or show your work. Part D for number 15 is a negative 20 plus something equals 5. So this one I will do with a number line, and then I will show you with the variable. So I'm down here at negative 20, and I have to get way up to 5. So let's see, if I have negative 20, negative 19, negative 18, negative 17, negative 16, negative 15, so that's a negative 15, negative 14, negative 13, negative 12, negative 11, negative 10, that's a negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Keep running out of room. Jeez. Okay, so the answer that belongs in this blank is the number of tick marks it took me to get from 20 to 5. So if I count those, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it took me 25 tick marks to get from negative 20 all the way up to 5. But what if we were solving it with a variable? If we had a variable, we could write negative 20 plus the variable of our choice, which I chose m in this case, equals 5. So to get the m all by itself, I have to get rid of this negative 20, or subtracting 20. So I have to do the opposite of subtracting 20, or I have to do the opposite of negative 20. I have to do it to both sides. On the left side, they cancel out because a negative 20 plus a positive 20 is going to be 0, again with the whole opposite thing. So that is going to leave just an m on the left side, and then you have 5 plus 20, which is 25. Hey, look at that. No number line needed. But again, if the number line works for you and you know that you can get the right answer with that, definitely use that. If you know that you can get the right answer with a chip model, use the chip model. If you know you can get the right answer with a variable, use the variable. Use whatever you need to, because some methods are easier for other people than other methods, okay? The second part, C, apparently I just noticed I did not change the letters on those, my apologies, is a negative 22 minus 5. Now this one is a subtraction problem, so I can add a line and change the sign of the 5. So this now becomes a negative 22 plus a negative 5. So because I am adding numbers that have the same sign now, it's a negative times a negative, I can add the numbers and then keep the sign. So I have a 22 plus 5 is going to be a 27. And then the sign, the original sign of both of the numbers was negative. So my final answer for this is going to be a negative 27. This is for the second part C again. And for the second part D, you have a blank plus a 9 equals a negative 9. Okay, so this one, again, you can use a chip model, you can use a number line, you can use a variable. I'll start with the chip model, and then I will show you the variable. So right here I have 9 positive chips. 9 positive chips. And then I have 9 negative chips over here. So somehow I have to get all of these positive chips crossed out because there are none over on that side. So these all have to go away. The only way for those to go away is if there are 9 negative ones over here to cancel them out. So I know I at least have 9 negative ones over there. But if I just have 9 negative and then 9 positive, I would have nothing on the right side. But I don't. I have 9 negative chips. So I need 9 more negative chips on this side in order for them to end up in the answer. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so because when I do my cancellation, I'll have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. Leaving me with the 9 negative chips that I wanted. So the total number of negative chips that I started with was 18 negative chips. So negative 18 is going to be my answer for this one. Like I said, though, you can solve it with a variable. If I did, you have your variable plus 9 equals negative 9. In order to get the variable by itself, you have to get rid of this plus 9. So you do the opposite to both sides. This cancels out. And so you are left with a r on the left side equals a negative 18 because you're adding two numbers with the same sign. So you add them together and then keep the original sign. That is negative 18 for that.